Institute of Engineering and Technology.
Good morning, students. Today we are going to cover the second part of method of undetermined coefficients, which is a technique to find particular integral as a part of general solution of higher order differential equation. In my previous video, I already discussed the first part, in which we have seen the method of undetermined coefficient where differential basis and elements of complementary functions were linearly independent. Today, in this part, my focus would be on what to do if these two components, means CF and differential basis, are linearly dependent. So let us go through the method. And the first step is to consider the equation into operator form, and for that I am taking second order differential equation y double dash plus c1y dash plus c2y equal to rx. As usual, rx is a random function of variable x, y is dependent variable on independent variable x, c1 c2 are arbitrary constants. Operator d is d by dx. Now, considering this operator d, given equation will turn into d square plus c1d plus c2 times y equal to r of x. And for that, we can take the differential form f of dy equal to r of x. Now, there are three main techniques: direct method, method of undetermined coefficient, and method of variation of parameter to find particular integral. Here we are focusing on method of undetermined coefficients part 2. Let us begin with one example. See, in this example we have y double dash minus 2y dash plus y equal to e raised to x. Operator form would be d square minus 2d plus 1 y equal to e raised to x. For complementary function, I am taking auxiliary equation f of d equal to 0, and therefore it is d square minus 2d plus 1 equal to 0, m1 equal to m2 equal to 1. These are two real repeated rules for given auxiliary equation. Now, for this, complementary function will be c1 plus c2 x into e raised to x, and then I am taking e raised to x in multiplication. So it will result into c1 e raised to x plus c2 x raised to x. Now coming to the main part, how to identify the differential basis. So here on the right hand side of equation, rx is e raised to x. All possible derivatives of e raised to x are considered, and they are e raised to x only. So along with function, all possible derivatives can be generated by only one element which is considered into this basis, which is e raised to x. Now let us check whether there is any repetition or whether there is any dependency in between this element and elements of CF or not. We can see clearly that element of basis is e raised to x, and there is repetition over here in complementary function, that is e raised to x. So we need to revise our differential basis. The rule to revise differential basis is to multiply each and every element of this set by free variable x. Okay, so here I multiply e raised to x with x. Then again I will check, is there any repetition in between this new basis and complementary function or not. Here you can see it is x e raised to x, and still, so dependency by this e raised to x is now converted into the independency, but this second part, x e raised to x, it is now repeated, and therefore we need to revise our differential basis once again. So again I am multiplying it by x. So it is x square e raised to x. So now this is the last basis which we obtain. So we need to compare our complementary function with this x square e raised to x. So here you can see now x square e raised to x is linearly independent with e raised to x, and it is linearly independent with x e raised to x also. And that means this is final differential basis. So we can take now this as our element of yp. So now I am generating particular integral as a x square e raised to x. Pause at this stage, again revise this process, as this is the most important part of undetermined coefficient, where the elements of differential basis are repeated, or you can say dependent linearly on complementary function. The rule is, if your elements are repeated or if they are linearly dependent, you should multiply each and every element of differential basis by x until all elements are linearly independent from elements of C. Okay. Now, once we have this formation, now we can come to our regular technique. So now we know that yp is a particular solution, so it can work as a solution of differential equation. So coming back to the equation, check how many differentiations are required for y. We can see clearly that it requires double derivative. So I'm taking y dash, y double dash. Here I am taking multiplication rule for differentiation. Okay, and then considering this y dash, y double dash into my equation on the left hand side, and then on the right hand side I have x e raised to x, and on the left hand side I have different possibilities like x square e raised to x e raised to x, and e raised to x. So combining all this coefficients of x square e raised to x e raised to x, and e raised to x on the left hand side, and writing on the right hand side exactly same components with coefficients accordingly like 0, 0 and 1. Now, once we compare both sides, we will get, see here, it is 2a minus 4a plus 2a, so it is 0. If coefficient is 0, this part must be 0. This will help you to cross check whether your simplification is correct or not. This part is 0, so here eventually you are receiving answer 0. This part is 2a and that is equal to 1, so we get the information that a is equal to 1 by 2. Now, sometimes it may happen that you are receiving value of a from more than one equations. So if your method is correct, if your calculations are correct, all those value will give you same answer. Means value of a by all three different equations must be same. Now considering this value of a into yp will give me answer 1 by 2 x squared e raised to x. Now let me take this yp with complementary function, that will give me final answer. Now, in my last video, I also told you that you should always cross-check whether your general solution is correct or not, and how we can identify that thing. See, the element of yc, they are e raised to x and x e raised to x. Remember one thing, that there cannot be repetition of functions in CF and PI. And so here you can see the PI over here, x square e raised to x. This function is independent from x e raised to x and e raised to x. This must happen. Otherwise, what will happen? This function will merge into this 2 and there won't be any role of PI. You need to take care of this thing. Now, let us consider direct method. See here, you know that it is very easy to solve this equation using direct method. So if in exam you are getting question specifically for method of undetermined coefficient, then and then only you should adapt it. Like here, see, you can directly take d square minus 2d plus 1 in denominator of this yp. So yp will be 1 by yp will be 1 upon d square minus 2d plus 1 on e raised to x. And the rule for e raised to x is very simple. We are replacing this d by a. So here you will get 1 minus 2 plus 1, which will give you answer 0. And so we need to multiply by x and we need to take derivative. So it will give you 2d minus 2. Still, if you replace d by 1, it will give you answer 0. So we need to take one more time derivative and we need to take multiplication of x outside. So it will give you x square into d. And finally 1 upon d simply means integration. So integration of e raised to x is e raised to x. So again, you can verify that your answer is exactly same, 1 by 2 x square e raised to x. So sometimes it may happen that a direct method is comparatively easy than applying method of undetermined coefficients. But remember, method of undetermined coefficient is only applicable if you have finite differential basis. For example, suppose you have on the right hand side 10x. The derivative of 10x is x square x, and derivative of x square x will expand. So this method is limited for functions with finitely many elements into the differential basis.
LJ Institute of Engineering and Technology.